Okay, when we're talking about vector, the directional of the arrow of the vector is going to be very crucial, so pay attention with that. Okay, so now before we go to this question, I'm going to explain how the vector works. Okay, so let's say I have point O over here. Point O is actually the origin of a Cartesian plane like this, right? So that's the O, but I'm not going to draw that for now. And then let's say I have another point, let's say over here, I name it with P, point P. And then if I drag a line from O to P like this, and then I mean, like if we have a straight line, a vector from O to P, and then it goes from O to P, right? Let's name that with X, for example. This is vector X, which means that if I have another vector like this from P to O, for example, P to O, going down backwards, that will be a negative X, right? So it's just like the opposite operation of that, the opposite sign of that. Okay, so that's the first one. The second one, I can actually move this anywhere I want. For example, if I have another point, let's say this is R, for example, and then I have Q over here, for example, and then I drag a line, and this line is actually the same thing like this one, right? So we can name this vector as X also because it's the same thing, right? We can actually move them around, just move them around. I can move everything and it doesn't change. It's just vector X, yeah, the X vector. Yeah, because we name it with X, yeah. This is just X, everywhere you want. Okay, and then if I going backward, and I mean like we have the same exact line, but it goes backward, it will be negative X. Okay, so that is the first concept. Okay, and then the second one is if I have another vector. For example, I have vector O. Say I'm going that way from O to point S, for example. Let's name this with y, vector y. Okay, so the same thing, yes. So I can just like move this around and go anywhere I want, and it's still the same thing. It's still y vector because the direction is the same and the length is the same, right? The direction is the same and the length is the same. So we call it. Well, we still going to name it with y everywhere it goes. But if we go to the other direction, for example, if going that way, sorry, it's going that way, so that will be minus y. Okay, so that's the second one. The next thing is that what if we combine two or more vectors? For example, if I want to combine, for example, I have a point, for example, this is px, so sorry, op, and then I have, for example, like this, the s, right? This I'm going to name this with x, and I'm going to name it with y. So, for example, if I want to go to a certain point, for example, like going this way here, right? And then how can I go from O to that point? I can just like go straight, right? But we can actually, but we don't have a name for this, for example. But I can go to alternatively using other vectors. For example, because I have this x and y vector, I can like, okay, I'm just copy this, right? Remember that if we move that around, it doesn't change the name. So I'm gonna go put that, okay, like this, right? Okay, notice that when I combine those two, right, that will be going to this specific point that I want to put on. I mean, like, for example, this is point R. So I can say that OR from O to R is going to be equals to OP, right? From O to P, and then P to R, for example. And then I know that OP is vector X, and I know that PR is actually the same thing with this one, which is OS. OS PR is equals to OS, and OS is equals to Y. So I can name it with Y. Okay, so that's the basic concept of that. So if I move backward, for example, I have another point in here. Let's name that. Okay, wait. Let's name that with T, for example. I point T. Right. So how can I go to O to T using the X and Y vector? So I can use the same thing. Like I can go from O to T, for example. I'm going that way, right? By just using P, right, going O to P, going that way. But this time, I'm going to use the O to S, but in different direction. So like this, so different direction like this, right? Maybe my drawing is not too exact, but yeah, you get the point, right? But this time it's not going that way, because from O to P, right? Okay, I'm going to write down. So OT, this one, is equals to OP, but it's going to be the different direction as the OS, right? We know that the vector y is going that way, but this line is the same length as OS, but the direction is going opposite. So which means that it's going to be minus, right? It's going to be minus of OS. So since we know that OP is X and the OS is Y, so it's just X minus Y. So it's going there and going there, and the same thing like this one. Okay, so that's the basic concept of how to construct like an equation for a vector. Okay, now let's go to this question over here, right? And the first one is being asked is, right, in terms of A and B, the simplest form of from point A to point B. Now again, the only like the basic concept is that where you start and where you end, right? You start from this point here, point A, and then you end at point B. So this is the end point, right? So now how can you use this vector, the red one, and the yellow, the green one, the B, to construct this vector. Now if we go from A, going from A to B, right, you can actually start from A and then going other way, right? So you can go this way, sorry, going this way, right? But instead, because we know that it's going this way is the opposite operation as vector A, so that'll be negative A, right? And then you use that negative A, and then after this you go that way, and we know that this line here is the same as B, right? So it's going to be plus B. So, or we can rewrite that as B minus A. That's it, yeah? So it's just B minus A. Okay, before we go to question B, I'm gonna tell you another concept. So if I have the line as like this, for example, and I know this line have a length of 10 units, for example, and then I have a point over, let's say it's over here, right? So this one and this one, the ratio is 1/4, for example. So I can actually know what's the length of, okay, so maybe we can use like 2 points, P, Q, and M, for example. So I can actually, because I know the ratio is 1/4, right, the PM by PQ, which means that I can just like divide, know the length of from P to M from Q. So if we have 10 units, which means that this line over here, the length is just 1/5. Where do I get the 1? Because this is 1, and where do I get the 5? It's just adding these two numbers, because 10 unit is the total, right, from P to Q. It's the total. So we need to add these two numbers. So just multiply by 10, because this 10 unit, they'll be just equals to 2. So which means that this is going to be 8, right? Because 2 plus 8 is equals to 10. So you can actually do the same thing with this question over here, AM. So since we know that AB vector is equals to B minus A, and we know that from A to M we have this ratio here, right? AM by MB is 3/2, so this is 3 and then this is 2, right? So which means that when we want to find AM, so we can use this 3, right? That'll be just equals to 3 over 3 plus 2 5, which is, and then multiply by the AB, right? Because this AM is part of the AB, right? So since we know that the AB is B minus A, right? So you only need to multiply and open the bracket. So go here, there will be 3/5b minus 3/5a.